Hello everyone, welcome to my channel Chemistry by ANR. We are going to discuss about preparation of alkenes. If you find organic to be difficult, then I can say that do follow my channel in order to understand in a simple manner. From alkynes we can obtain alkenes. How can we obtain? By the method of hydrogenation we can obtain, that is addition of hydrogen. Here we can see hydrogen is getting added, but if we add 1 mole of H2, then we are going to get RCH double bonded CHR dash. Now this is a controlled reduction. This is known as controlled reduction. Why it is controlled reduction? The reason is if I reduce it further, I can obtain the alkane as the final product. So this is done with, it is partial reduction or controlled reduction with calculated amount of hydrogen in presence of palladized charcoal, which is deactivated with sulfur or quinoline. So PDC in presence of sulfur quinoline. Why? Because they are acting as catalyst poison. Why do we need catalyst poison? Because it is a controlled reduction method. So we need to deactivate the catalyst. And this partially deactivated palladized charcoal is known as Lindlar's catalyst. So how to obtain Lindlar's catalyst? You need to deactivate the palladized charcoal using sulfur or quinoline. Now we can see this is a controlled or partial reduction as well as selective in manner, that is selective reduction. Why? Because if you change the catalyst like PDC or sulfur quinoline, which is together known as Lindlar's catalyst, if you use Lindlar's catalyst, then you will get cis alkene. But if you use sodium in liquid ammonia, you are getting trans alkene. So it is a selective reduction, or I can say a stereoselective reduction process. So how to obtain cis alkene or trans alkene? You need to know what are the catalysts to use. Next, ethyne is a specific example. Using PDC, since it is a symmetrical alkyne, in this case cis-trans is irrelevant. Had it been substituted like in this case here, then I can talk about cis and trans. So this is the other one, PDC. Here again hydrogen is added on both the side to get an alkene. So will propene thus obtain show geometrical isomerism? It is of what type? If I see this carbon and this carbon has one alkyl group. Say this is one alkyl group. So A. This is B. And here it has B 2 times. So I can say BB type. That is, it is CAB double bond CBB type, which doesn't show geometrical isomerism. In order to show geometrical isomerism, it should be CAB double bond CAB type. Then only it will show cis and trans isomerism. Next, from alkyl halide. What is alkyl halide? It is RX, alkyl halide. On heating with alcoholic KOH or NaOH, potassium hydroxide, it eliminates one molecule of halogen acid to form alkenes. Halogen acid to form alkenes, it means actually it is a dehydrohalogenation reaction. So keep this thing in mind that it is dehydrohalogenation means minus HX. Hydrogen and halogen is getting removed. Now halogen is present in alpha carbon and this hydrogen is the beta hydrogen. So this is known as alpha beta elimination or simply beta elimination reaction. Why it is known as beta elimination? Because the hydrogen which is eliminated is from the beta carbon. The hydrogen is from the beta carbon. Now, how do we know what is a beta carbon? The carbon to which the functional group is attached. In alkyl halide, X is the functional group. This carbon is alpha carbon. Adjacent to it is the beta carbon. And if I have more than one beta carbon, then I will get multiple product. So I can say as many types of beta hydrogen, that many alkenes will be obtained. That many alkenes will be obtained where the more substituted alkene is the major product. Okay, so this is as per Sadzev's rule. Some of the book you may see it is written ZSAF. Both you may get to see. So as per Sadzev's rule, it is the most substituted alkene is the major product. Here we are not having any such chance. I will show you how to see the major product. Now, nature of halogen and alkyl group will determine the rate of the reaction. So, rate of the reaction depends on number 1, type of halogen. So, type of X. Remember that it is greater for I, that means Ri greater than Rbr greater than Rcl. Why? Due to better leaving character of I minus than Br minus than Cl minus. Better leaving character means in this bond, if it is a carbon to iodine bond, then I minus will get eliminated easily than Br minus than Cl minus. And what is the reason behind it? Because the bond enthalpy of Ri is less than Rbr is less than Rcl. So Ri will break easily and produce I minus, and so the reaction rate will be faster. So this is number 1 point. Number 2 point is type of the alkyl group. So number 2 is type of alkyl group. For a 3 degree, it is greater than a 2 degree than a 1 degree. Because if it is a 3 degree, then I will get more than one type of beta, and as many beta, that many products, and the reaction rate will also be fast, right? So let us see one such example. Because here one more thing, let me tell you that alcoholic KOH, what is the function of it? It acts as a base, on account of which this base abstracts the acidic proton, which is the beta H, forms a double bond between alpha and beta carbon, and X minus leaves. Now, there are certain things you need to understand. First thing, why these H are acidic in nature? Why the beta H in Rx is acidic in nature? The beta H in Rx is acidic in nature because if this is X and here there is H, then in that case, on account of the polar nature of this CX bond, X gets a partial negative charge and C gets a partial positive charge due to the electronegativity difference between halogen and carbon. So there is, on account of this electronegativity difference, there is the electron pulling effect towards X, and so for which these H, which are beta adjacent to the alpha, they are acidic in nature, and so they can be given out to a base. So suppose I say I am writing CH3, CH2, say there is again a CH, here there is a Br, so here there is a CH3. So how many products do I get if I use alcoholic KOH and heat it? Remember, this should be alcoholic, and this mentioning that it is alcoholic is very important, because if I use aqueous KOH, the mode of the reaction will only change. My major product will be alcohol. But here, since I am using alcoholic KOH, my major product will be alkene. And remember that I told you this is alpha carbon because it has Br. Adjacent to the alpha is beta, so this is beta 1, this is beta 2. And here I will get a double bond between alpha and beta 1 by the elimination of H from beta 1 and Br from alpha. So I will get CH3, CH, double bond CH, CH3. Because there was alpha, carbon say Br, and beta 1 say H elimination. So this is the first product. Next, I can get elimination from alpha Br, and from beta 2 I can get H getting eliminated. So there will be a double bond between alpha and beta 2. So CH3, CH2, CH, double bonded CH2. This is another product, because I said as many types of beta H. So mark my word, I did not say as many beta H. There can be many beta H, but as many types of beta H. What is the chemical scenario? What is the chemical environment? For that you can take the help of numbering in nomenclatures. The position should not be identical. Then only they are of different kind. Now, here we can see out of these two, which is the major product. Now I said the more substituted alkene. To see the more substituted alkene, you need to focus on C double bonded C system. So focus on C double bonded C system. Here we can see the system has 2H. This is one, this is other. And here there are 3H. This is 2, this is 1. So which is more substituted? The one which is containing less H. So this is your more substituted, and so this is your major product, and the other one is your minor product. So this is how we can apply the concept. Next, from vicinal dihalide. Vicinal means 1,2 dihalide, 1,2 position. Adjacent positions, there will be dihalides, and it is known as dehalogenation. The meaning of the term dehalogenation means minus X2. But remember, this reaction takes place with zinc metal. Zinc is a bivalent metal. It actually loses a molecule of ZnX2 to form an alkene. So remember that the two adjacent carbon which has the halogen will lose both the halogen and form ZnX2 as the side product. See, these two halogens are lost. Next, from alcohols by acidic dehydration. This is again another important topic of class 12. From alcohols by acidic dehydration means the medium should be acidic in nature, and dehydration means removal of H2O. Removal of H2O in presence of concentrated H2SO4 and heat. This is again a dehydrating agent for which the reaction is driven forward using a dehydrating agent. Remember again, this is alpha beta elimination of OH and H. OH and H. Why? From alpha carbon, OH is leaving, and from beta carbon, H is leaving. And here you will get alpha beta unsaturated compound or alpha beta alkene unsaturated product. Now remember, the temperature over here should be 443 Kelvin, a higher temperature. And at this temperature, there is elimination of beta H. Now again the same thing, as many types of beta H, that many products will be obtained. That many products will be obtained, out of which the most substituted alkene, will be your major product, So this is again another thing. Now you have to see this like concentrated H2SO4, how this is taking place, what is the mechanism. Let us try to see. This is CH3, CH2, this is CH2OH. So here there is OH, here there is another H. Here again, if I use H plus, why H plus? Because I have concentrated H2SO4. The lone pair above oxygen, this abstracts H plus and it forms protonated alcohol, because this is alcohol. And what is the name of the alcohol? Here it is ethanol. Because in order to form an alkene, you need minimum 2 carbon atoms. So you need alcohol made of 2 carbon atom in minimum. So now you get CH3. It is like this, CH3, CH2, and you got oxygen was there, H was there, and it has used one lone pair, so another lone pair remaining. It has abstracted H and used one lone pair, so a positive charge. This is known as protonated alcohol. Protonated alcohol, and protonated alcohol has a general term which is known as oxonium ion. It is oxonium ion. Now remember that this here in the medium there is H2O. This H2O, what it does is it abstracts this proton, forms a double bond, and there is elimination of this H2O. So what is happening over here is, you can see it in this manner. There is elimination of H2O, or you can see it the other way also. I'm showing you the other way also. That is the more probable way and easy to understand, and that's the more probable mechanism. See, mechanisms are all probable things. Now, since another probable thing is, since oxygen is electronegative, it has a positive charge. So it wants to get rid of the positive charge. So what it will do? It will take the electron pair and get dehydrated, removal of H2O. Now this will be favorable if you start with a 3-degree alcohol, then a 2-degree, and then a 1-degree alcohol. The reason is because you are getting a carbocation here. And this step is your slow RDS. See, after the removal of water now, it's dehydration minus H2O, you are going to get CH3 like this, and you will get CH2 plus. So this is the carbocation. Here I know it is a 1-degree, carbocation is very less stable, so I was going to show you the other way round of the mechanism. So had it been a 3-degree, then this carbocation would have been highly stable. Had it been a 2-degree, would have been more stable than a 1-degree. So for a simplified version of the mechanism, we are going to discuss with 1-degree. Now here in the medium, due to the elimination of H2O, what happens? Due to the elimination of H2O, we know water has amphoteric behavior. So it abstracts this proton and it forms a double bond here. So on this proton abstraction, we are left with CH2 double bond CH2, which is an alkene, and H3O plus is regenerated. What is H3O plus? H3O plus is H plus and H2O. We started with H plus and H2O only, acidic dehydration of alcohol. So we started with H plus and H2O. H plus comes from the H2SO4. So it is again regenerated. So catalytic amount of acid is required to drive the reaction forward. So these are the things. See a gist of it. Do recall all the points. How to get a selective product, cis-alkene, trans-alkene, changing the catalyst. What is Lindlar's catalyst? What is the function of sulfur or quinoline? Then what type of product you will get by the dehydrohalogenation reaction? Why it is beta elimination? Why the beta hydrogen is acidic in nature? Rate of the reaction depends on what factors. Then here vicinal dihalide losing X2 and forming ZnX2. And finally, acidic dehydration of alcohol and its mechanism. So the topic of preparation is still this. We will discuss about chemical reactions in the next module. Till then, bye all of you.